Hi, in this video, we're going to solve three consecutive problems appear in JEE main. So here we have three problems. First one is from sequence and series. Second one is from complex number and also the third one. So let's go ahead and start our journey on solving these three problems. Let's go ahead. This problem, we have to find out the least positive integer n such that the given series given in the left hand side of the inequality is less than 1 by 100. So to solve the problem, first we have to find out the summation of the left hand side in terms or as a function of n. Then we have to solve that inequality to find out the least n. Let's go ahead and see how we solve it. We take that series. S is equal to whatever given as a series term. Now here if we observe, right, from the second term onwards, 2 is a common term. So we are allowed to take the common as 2. So if we take the 2 term or the number 2 common from this series, we can easily rewrite it as 2 multiplied by 1 by 3 plus 1 by 3 square and so on. Now here if we observe, if we multiply in that particular series which is marked or shaded as some color, right? If I multiply by the first term by 1 by 3 and if I again multiply second term by 1 by 3, we get the third term. And obviously this is go on up to the last term. So therefore, this series, right, is an GP series with first term A1 is equal to 1 by 3 and the common ratio R is also equal to 1 by 3. So now the number of term is obviously n minus 1. So therefore, we can easily add them using the formula of the summation in GP series. We know that for a GP series, if the first term is A1, common ratio is R, then the summation of first n term is A1 into 1 minus R to the power n divided by 1 minus R if R lies between minus 1 to plus 1. So if I use that here, A1 is 1 by 3, R is 1 by 3. So therefore, by simple calculation after substitution, we can easily find out the sum of that particular shaded series is 1 by 2 into 1 minus 1 by 3 to the power n minus 1. So we can easily substitute that in S. So if we do that, right, we can easily calculate that it is actually equal to 1 minus 1 plus 1 by 3 to the power n minus 1. Basic simple arithmetic. Now 1 and 1 get cancelled out. So the sum is 1 by 3 to the power n minus 1. So therefore, we are able to obtain the value of S as a function of n. Now our next part is how we solve the inequality. Here it is given that the summation S or the sum S is less than 1 by 100. So therefore, it is obvious that 1 by 3 to the power n minus 1 is less than 100. Doing the cross multiplication, we can find 100 is less than 3 to the power n minus 1 and thus 3 to the power n minus 1 must be greater than 100 and hence 3 to the power n is greater than 300. Now we have to find out the value of n so that this inequality is satisfied. Observe that if I go ahead and see 3 to the power 2, it's 9. 3 square is 27, 3 cube is 27, 3 to the power 4 is 81, 3 to the power 5 is 243. So these values are always less than 300. But if I multiply now by 3 to the power 6, it became 729. So therefore, if n is greater than equal to 6, then this inequality will satisfy. So therefore, the inequality will be satisfied if the lower value or the least value or the minimum value of n must be 6. And hence, for this problem, option C is the correct answer. And that's it. So this is a simple problem. Now, let's go ahead and solve the question number 2, whatever you already seen. Let's go ahead. The second problem which we chosen from complex number, we have to find out the least positive integer n again, but for which the 1 plus I root 3 divided by 1 minus I root 3 whole to the power n is equal to 1. So here our main job is to simplify the complex number and find out for what values of n it is 1. So let's go ahead. So here first we consider the complex number z as 1 plus I root 3 and 1 minus I root 3. So to solve this problem, we can multiply the denominator and numerator by the complex conjugate of the denominator and we can proceed. But before going ahead, we can also use the concept of cube root of unity. Now, if we know that, right, that omega is the cube root of unity, then omega cube must be equal to 1. 1 plus omega square must be equal to 0. And omega is the root of the equation x squared plus x plus 1 equal to 0. And hence, omega will be minus 1 plus I root 3 divided by 2. And omega squared, obviously, is conjugate. Now, if I multiply it by 2 and rewrite, we can easily find out 1 minus I root 3 is minus 2 omega and 1 plus I root 3 is minus 2 omega squared. So see that our denominator and numerator in the complex number z we already obtained in terms of omega. So therefore, our z is equal to minus 2 omega square and divided by minus 2 omega. 2 get cancelled, minus get cancelled, and 1 omega get cancelled. So therefore, basically, our complex number z is omega. Now, we need to find out the value of n so that omega to the power n is equal to 1. It is obvious that z to the power n equal to 1. Hence, omega to the power n equal to 1. We know that the omega cube is 1, omega to the power 6 is 1, and so on. So therefore, the least positive integer n, so that omega n equal to 1, it must be 3. And hence, option B is the correct option. And it is a very simple problem if we recall or able to recall the concept of cube root of unity. Otherwise also you can try by multiplying by the complex conjugate or maybe rewrite it using the polar form or Euler formula. Just try that. Let's go ahead. Third or last problem for this video, we have to find out the complex number z and whichever option are equivalent. So let's solve it. We consider the complex number z, which is as I minus 1 divided by cos pi by 3 and I sin pi by 3. So that's why we consider it as z1 by z2, where z1 is the numerator and z2 is the denominator. See that the numerator is I minus 1, which can be written as minus 1 plus I form. Now see that as in all the option, right, the angles are provided in cos theta plus I sin theta form or in polar representation. So our aim is it's better that we convert the numerator as in polar form, and let's proceed. Now we all know that, right? Any complex number z is equal to x plus iy can be considered as or can be represented as r cos theta plus r sin theta form, where r is the modulus of z and theta is the argument. So here to rewrite in the polar representation of z1, if we compare z1 with x plus iy, we find out x is equal to minus 1, y is equal to 1. So obviously the mod of z1, which is x square plus y square, that is root 2. And also observe that point z1 equal to minus 1 plus I definitely lies in the second quadrant. Now, as it is lies in the second quadrant, so therefore the argument of z will be pi minus tan inverse of mod y divided by mod x. This is a simple formula. Now, y and x is equal to 1 each. So therefore, it is pi minus pi by 4 and that hence 3 pi by 4. So therefore, mod z or z1 actually is a complex number with modulus root 2 and argument of z as 3 pi by 4. So therefore, the complex number z1 can easily be written as root 2 cos pi by 3 pi by 4 minus I sine 3 pi by 4. So we obtain the polar representation of z1. Now, we also now able to recall as z1 by z2 is there. So we can say that it is equal to root 2 cos 3 pi by 4 minus I sine 3 pi by 4 divided by again cos and sine term. So from here, maybe we can multiply the denominator and numerator by the conjugate and proceed, but which takes a lot of time. So that's why here we will recall the Euler formula. What is Euler formula says? E to the power ix is cos x plus I sin x and e to the power minus x is cos x minus I sin x. So if I use this formula in Z1 and Z2, then we can easily obtain Z1 is root 2 e to the power I 3 pi by 4, whereas Z2 is e to the power I pi by 3. So therefore, using that, we find out Z can be, or the complex number Z can be written as root 2 e to the power I 3 pi by 4 divided by I pi by 3. Now see that it is a concept of now indices. So therefore, the final answer will be root 2 e to the power 3 pi by 4 minus pi by 3. Now we can easily subtract by the LCM, normal LCM method or basic arithmetic. What is 3 pi by 4 minus pi by 3? So 12 is the LCM, and if I calculate, it is I 5 pi divided by 12. Again, if I come back in the Euler formula, so therefore e to the power ix or e to the power I 5 pi divided by 12 can be written as root 2 cos 5 pi by 12 and I sine 5 pi by 12. And hence, it is obvious that option D for this case is the correct answer. Hope you understood all the three problems. If it's helpful, please comment it down and we'll glad to answer your comments whenever is possible. So thank you. Keep learning from our side. Hope we'll see you in our next video. Thank you.